This is the Earth Science Classroom. Welcome back, everyone. Now, when I'm discussing sedimentary rocks and weather and erosion, one key aspect we have to really discuss in detail and make sure the students understand this process and this principle is surface area and how that affects the rate or the speed of weathering. Now, that could be either mechanical or chemical. In terms of the speed between both types, chemical is usually a slower process than mechanical. Also depends on the environment. Depends what is being broken down, what kind of rock, what kind of minerals and compositions in the rock. But generally, you need to understand that surface area plays an important role. Now, I'll take this one cube of rock. It could be an igneous rock, it could be metamorphic rock, or it could be a pre-existing sedimentary rock. So sedimentary rock is generally softer, generally easier to weather compared to a metamorphic or igneous rock. Igneous rocks tend to be made up of minerals that are first in the Burns reaction series. That means that they are chemically more unstable than perhaps the metamorphic or sedimentary. So what's going to happen is this cube of rock, this source rock, has a total of 6 sides. Okay, this shape is three-dimensional, 6 sides. So there are 6 sides that are exposed to the elements and therefore weathering mechanically and chemically. Again, we assume that there is uplift, and this rock is on the surface. Now, if, let's say, the rock is going to break, and the breaks in the rock, okay, they're not an angle, they are called joints. They are breaks, clean breaks in the rock. They produce gaps in the rock. And once there is a gap, then you get the agents of both mechanical and chemical weathering going into the gaps and thus creating a larger and larger space or void. And eventually what you get is this outcome where the single block has 6 sides is now broken into 4 distinct smaller blocks. And these 4 blocks now have 6 sides per block. So we have a total of 24 sides that are now exposed to the elements. Therefore, this will be a faster rate of weathering compared to a slower rate right here. But the transition between them, this is the breaking down of the rock. It starts here, and then it ends up in the 4 smaller blocks, and then down into smaller and smaller bits. Now, the classification of size comes with plastic sediment differences. For example, like pebbles and gravel are larger compared to sand and clay and silt granules, which are smaller. So the different sizes would relate to the different names we give them in terms of the classification. Again, surface area, very important process to make sure your students understand and appreciate, and the speed at which this happens and the environment can control or dictate how fast this process happens.